Hi, I'm Terry VanNoy. Thanks for watching this video. We're talking about logarithms and how sometimes you have to change the base of the logarithm. Now there's something called the change of base formula. I'm going to introduce it to you in this video, and then we're going to get to a problem set of problems I want you to try on your own, and I'll go over it after you have a chance to work on it. And then we'll finish this video series with a self-quiz. So it should be a 3-video series. Alright, the logarithm change of base formula is this. And what that basically says is that you have a log in some base b of m. What you can do is change the b base into some other base I've labeled a. Now a lot of times, because of the way calculators are used, we use log base 10. So we convert the log base b into log base 10, and it's a ratio, as you can see here. Now I'm going to give you an example of two ways to do this by changing things into log base 10. Alright, this example says log base 3 of 81 equals what? Now normally, to figure out what our unknown is, we'll call it x for now, what we could do, if the numbers work out nicely, is we can convert this logarithmic form into exponential form. And it basically goes back to what a logarithm is. The logarithm is the exponent of the base. In other words, 3 to the what power is 81. So let's write that in exponential form. 3 to the what power equals 81. So this is 3 to the what power equals 3 to the fourth. 81 is 3 to the fourth power, right? All right, that means that the x has to be 4. There's our answer. Now if we use the change of base formula, let's prove it. If we're going to change base 3 logs into base 10 logs, we write it like this. Log of 81 over log of 3. Remember, the base 10 is assumed. So on our calculator, we're going to type in 81 and find the log button. In this case, it's log base 10. And that's going to be 1.9084, and let's round it to 1.9085. Alright, then let's do log base 3. Excuse me, log of 3, base 10. So type in the 3, and the log of that is 0.477121. Let's call it 0.4771. Alright. Divide it out, and it's going to be a little over 4, and that's just because of the rounding we did here. Alright, so we know it works whether it's exponential form or the change of base logarithm form. And there are times when you just can't do it in exponential form because the numbers don't work out very nicely. Alright, I'm going to have you try a couple of examples. Alright, I'm showing you these 4 examples which you can do nicely with the exponential form. You can go ahead and do that, but let's practice with the change of base formula, and I'll show you both in just a moment. Go ahead. Alright, number 1, log base 5 of 1 over 25. Now let's go ahead and make that equal to x, and let's do it with the exponential form. That means that 5 to the what power equals 1 over 25. Now let's think of this in terms of 5. Let's say it's 1 over 5 squared, which is 5 to the negative 2 power. Therefore, x has to be equal to negative 2. Alright, we're going to check that with the change of base formula in a moment. But let's go to number 2. 2 to the what power equals 8. Well, we know that 8 is really 2 to the third power, and so x must be 3. Alright, again, I know it's a simple example, but we're going to prove it with the log change of base formula. Alright, let's look at 3 and 4. Number 3, log base 5 of 25. Well, 5 to the what power is 25. Well, we can kind of figure that out pretty quickly. That's got to be 2. 5 to the second power must equal 25. We'll use the change of base formula on that coming up. Log base 7 of 343. So 7 to the what power is 343. Well, we remember that, or at least we can figure out, that 343 is 7 to the third power, so x must be 3. All right, now let's grab our calculator and see if we can figure this out with the log change of base formula. Log change of base formula. So we're going to say log base 10 of 1 over 25 over log base 10 of 5. All right, so log base 10 of 1 over 25 is really log of 0.04 over log of 5. All right, now when you divide these out or hit the logarithm button on your calculator, I usually go to 4 decimal places, and the answer down below in these future problems will say 3 decimal places. But let's go to 4, and notice that the first one gives you, and you can check this on your calculator, negative 1.3979. Remember, I'm rounding that. And log base 5 is 0.6990. I have to round up on that one. And if we divide that out, we're going to get approximately negative 2. Okay, just as what we did with the exponential form. All right, let's do log 8 over log 2. All right, I want you to test your calculations. All right, you should have something about 0.9031 over 0.3010. All right, then you divide that out and you're going to get something very close to 3, hopefully, depending on your rounding. All right, on number 3, log base 25, log of 25 over log of 5 is 1.3979, rounded, of course, over 0.6990. We divide that out and it should be about 2. And last check here on number 4, we know we did it in exponential form and that gives us 3. Let's test our numbers. Do log of 343, 2.5353. Log base 7 should be 0.8451. And yep, when we divide it out, it'll be approximately equal to 3. All right, next video, we're going to be looking at these, changing the base here. Now notice how sometimes we have some decimal amounts. So come on back, watch the next video, and let's see if you understand log change of base formula.